Question 8, part A. Calculate the critical angle for light passing from flint glass to water. So if the refractive indexes are the same, it just goes in a perfectly straight line. So there is no deviation, which implies there's no critical angle. Total internal reflection does not happen in this case. In the second case, if we draw the boundary between two substances, the normal, and we imagine the path of a ray of light that hits the surface at an angle and refracts such that it runs along the second surface. At this point, this angle is called the critical angle, theta c, and this angle is 90 degrees. So in this particular case, theta 2 is equal to 90 degrees. So n1 sine theta 1 is equal to n2 sine theta 2, but the sine of 90 is equal to 1, so n1 sine theta 1 is just equal to n2. This now is known as the critical angle, so rather than calling this theta 1, we'll call it theta c. Theta c is the inverse sine of n2 over n1. And then the last bit we have to remember is that it's going from glass into air. So the sine of n2, the inverse sine of n2, but n2, the second medium it's in, is just air, so that's got a refractive index of 1 or 1.0 or 1.00. It came from this flint glass, which had a value of 1.33, so that gives us its critical angle, which is 48.8 degrees.